and welcome to the MC Squared Show.
On this episode, we're going to show you how to make an art pot.
Today is our first and last episode, so we hope you enjoy.
Our question is, which popsicle stick position will affect the bot most? Our hypothesis is, the center position will affect the bot the most.
Okay, now on to the materials. The materials we are going to use are one Bristol bot kit, which includes a 9-volt battery, a 9-volt battery holder, and a 9-volt DC motor.
We will also use a plastic cup, 16 ounces, not 8, 16. A cork, a popsicle stick, thin-sized washable markers, 4 of them, large eyes, which are already put on the cup, white poster boards, electrical tape, a hobby knife or scissors, which we will be using both, a small Phillips head screwdriver, a stopwatch, which will be our phone, double-sided foam tape, and our lab notebook, which will be our paper.
Now for the experiment. We're on to step 2, and step 2 is to put the 9V battery into the 9V battery holder.
Okay, we're on to step 3. So step 3 is to press the cork into the motor shaft. So the motor shaft is this part right here, and it's the long metal part sticking out of one of the ends. So this is what you're going to put your cork into.
Alright, now we're on to step 4, which is cut the holes in the cup for the mounting of the motor. Okay, so what we're going to do is flip the cup upside down, if you haven't already. And so we're going to cut 3 holes into the top. I've already made some slits, so I know where to start. So it's for one of the wires, for one of the motor wires and another one of the motor wires. And then it is also for one of the tiny shafts to be able to go in there. So first what we're going to do is line the motor up at the top of the cup so you can see about how far apart the holes need to be.
Now we're on to step 5. We're going to use the double-sided foam tape to mount the motor on top of the cup. So first, we're going to cut a small piece of double-sided foam tape . So, after we've got these 2 pieces of tape on each side, we're going to take this orange piece and put it on the tape. And we're also going to thread the wires into there. So let's thread those.
Mount the battery holder inside the cup. Okay, so put a piece of double-sided tape foam on the back of the battery holder. The side without the power switch, because it makes it easier to turn the switch off. So.
Step 7. Twist the motor and the battery holder's wires together. It is important to make sure your battery holder switch is still in the off position before you proceed with this step. Reach inside the cup and twist together the exposed metal ends of the red wires. So
touch, it could cause a short circuit in the motor. Sorry, in the motor, which can cause it to stop working. So, what you're going to do is cut some pieces of electrical tape, which you can see I did. And you are going to wrap them around the exposed areas where the silver is.
we're on to step 9. At this point, you should have a complete circuit because you have connected both wires from the battery holder to the monitor, or motor. Hold the cup with one hand and turn the battery holder switch onto the on position. As you saw, the cork started spinning right away.
Now, you need to use 2 pieces of electrical tape to attach the marker to the outside of the cup and make sure it is up and down and that the tip is at the bottom. And as you can see, and now Marlo is going to help me set this up.
Step 11. We're going to attach the popsicle stick to the cork. So you're going to take one piece of electrical tape, like so, and cut that into halves.
Alright, now on to the testing. Now that we've built it, we are going to be doing some tests. To test it, we will be placing the robot in the center of this board, and we'll be letting it run for 10 seconds. We will repeat this a total of 3 times. We will then adjust the popsicle stick so it is slightly off-centered, and in the center. It is off-centered right now. Finally, we will when we're done, we will compare the 3 poster boards to see how moving the popsicle sticks affected the way the robot moved.